Okay, today I'm going to show you something really interesting. So if you've watched my previous videos, you'll know I built this Tesla coil in 5 minutes. Then I connected it to my big giant transformer that's 50 kilovolt amps or 50,000 watts at 7,200 volts. So that transformer is feeding these capacitors and this tank circuit, which is an LC circuit. This secondary is only connected to the ground. It connects right under here, right there. It connects to the ground wire, and it has no connection to this primary coil or the transformer. It goes over there to this ground rod. Okay, now I'm going to show you the interesting part. So the top load or the top capacitance isn't tuned right now, so I will turn it on without it tuned. The metal objects on the top add capacitance. Okay, turning on the rotary spark gap. Now I'm throwing the switch. You see nothing happened. Now I will put, well, it sparked a little bit on there, but not much. Now I will put this on top of it. This will act as a capacitor, adding more capacitance. Just like that. Now I will turn it on again. So this was and still is my receiving coil for the magnifying transmitter. This primary of the receiving coil is wrapped to 1/4 of the wavelength of 168 kilohertz. That's a certain length of wire. So all I have done to make this receiving coil into a Tesla coil is I've added more top load capacitance, and I've added these outer turns for the primary. That's what the power is flowing into, and it flows at a certain rate. It flows at a frequency of 168 kilohertz, and this is wrapped to 1/4 of the wavelength of 168 kilohertz, as well as tuned to that frequency. So the capacitance and the inductance are what tunes this circuit. It's called an LC circuit. Okay, now I have put in a ground rod right there, or a little ground wire thingy, and I'm going to see if the coil will jump to it. Okay, here we go.